All right. Hello, everyone. Today I'll be talking about the scientific revolution. Now, this is a weird part in our AMSCO AP Euro textbooks because the scientific revolution is actually at the end of chapter 1. As you watch this video or after you watch the video, if you want to go to your AMSCO textbook, pages 15 to 20, the tail end of chapter 1, and you'll see about the scientific revolution. Talking about the causes of the scientific revolution, kind of what was going on in the background, some of the key discoveries and kind of some of the key themes and trends of the scientific revolution. So talking about the context of the scientific revolution first. The scientific revolution is a very gradual phenomenon. It's not like the Glorious Revolution where it happens all at once. Rather, the scientific revolution takes place over 200 years, the 1500s, the 1600s, and even the 1700s. So when looking at the context of what was happening as the scientific revolution starts up, we've got to look at kind of what was going on during the 1500s. We've got the Renaissance, we've got the discovery, quote unquote, discovery of the New World, we've got the printing press, and then we've got the Reformation. All of these events encourage people to be open-minded to new ideas and challenge what people used to think. So, for example, the Renaissance. The Renaissance is all about people coming up with the new idea of humanism, applying new ideas like secularism and individualism, studying new topics like the humanities, not just the classics and philosophy and morals and things like that. So the Renaissance begins this curiosity and openness to new ideas. Renaissance scholars also loved math. There's lots of mathematic principles hidden in lots of paintings and things like that. So first you've got the Renaissance that makes people curious in new ideas like humanism. Then you've got the quote unquote discovery of the New World, 1492 and the 1500s. And people throughout Europe, at least academics throughout Europe, all of a sudden are exposed to cultures and worlds and civilizations that they never even knew. They begin to question what they thought about about how best to run a society or something like that. The printing press also allows these ideas to spread, not just Martin Luther's 95 Theses, but scientific essays as well. And then all of the uncertainty from the Reformation, the Age of Exploration, the religious wars, again, challenges or pushes people to question what they thought they knew. So again, when we're talking about the context of the scientific revolution, kind of looking at the 1500s to 1700s, people are open to new ideas. We especially see that from the Renaissance, with humanism, individualism, an obsession with math. The Reformation, where people are questioning traditional sources like the church. And then the printing press allows ideas to spread. I should actually add the Age of Exploration. People discover new cultures. Again, discover should be in quotation marks there. They discover new cultures, which again, open to new ideas. And I'm actually going to add here, they question traditional ideas. So we have both an openness to new ideas, openness to humanism, to new ideas about religion, and people questioning traditional ideas, especially with the Reformation. Those two themes, questioning traditional ideas and openness to new ideas, is going to be one of the main driving forces behind the scientific revolution. Now, before we get to the new discoveries, we got to know how people used to think. The old ideas, and this is how people thought all the way up until the mid-1500s, was based on the Greeks. Ptolemy, I know his name is PT, but the P is silent. Ptolemy was an ancient Greek philosopher who came up with the geocentric theory of the universe. You might see the prefix there, geo, like Earth, center. So geocentric means the Earth is at the center of the universe. We know that that's not true, but that was how they used to think. Not only did Ptolemy, the Ptolemaic system, and other people think that the universe was geocentric, they also believed that there were only 4 elements, earth, wind, fire, and air. I think I got those. They also believed in perfect circular orbits, so the moon orbits around us perfectly. That is Luna. Mercury orbits around us perfectly. Venus, the sun, Mars, Jupiter, Saturn, etc., in perfect orbits. And they believed that God was the prime mover, that God was the one that put everything into motion and started it off. So again, the old ideas, this is sometimes called the Ptolemaic system, or just Ptolemy, and he was a Greek philosopher. They believed in a geocentric universe, which means the Earth is at the center. And they believed in perfect circular orbits. I'm going to bold this word geocentric and Ptolemy as well, because those are words that we might need to be familiar with. Now, the scientific revolution begins to introduce new ideas, new theories about science. Three main discoveries and people that I think you need to be familiar with. Nicholas Copernicus, around 1534. He is the first one to come up with the heliocentric theory of the universe. If geocentric means the Earth is at the center, heliocentric then means the sun is at the center of the universe. Galileo added on to what Copernicus discovered, and by using a telescope, he uses the telescope not to look at the Earth around him, but to look at the heavens. He discovers many things. First, he discovers the moon has craters, which proves that celestial or heavenly bodies are imperfect, that they're changing, so maybe they're not divine. He discovers that the sun has spots, again proving that celestial, heavenly objects are not perfect. And he discovers that Jupiter has a moon. Jupiter actually has several moons, but he discovers Jupiter has a moon, which makes him think, okay, if Jupiter has a moon that orbits around Jupiter, then the Earth must not be at the center, because everything doesn't orbit around us. So again, Galileo proved two things. He proves first that celestial bodies are imperfect. The moon has crater, the sun has spots, and the universe is not geocentric. So again, he kind of uses the telescope to collect observations to prove Copernicus's heliocentric theory. Now, he wasn't he didn't invent the telescope. The Dutch actually invented it, but he's the first one to use the telescope to look at the heavens. So he oftentimes gets credit for that. Now, he was called a heretic by the Catholic Church. He was placed under house arrest by the Catholic Church. We've got this little cartoon here. Galileo describes his discoveries to the church, and the Pope is imagining taking the telescope and whacking him over the head. It's to try to think about why. Why would the Catholic Church be offended by these discoveries? Well, if the Earth is no longer at the center of the universe, then humans aren't special. And what does that say about God? If God did not make humans at the center of the universe, what does that mean about humans? What does that mean about God? And if celestial bodies are imperfect, if the moon has craters and the sun has spots, again, what does that say about God? Did God create an imperfect object? And if so, is God imperfect? So all of these discoveries really challenged the Catholic Church, and the Catholic Church felt very threatened by this, feeling like their ideas were under threat from Galileo's discoveries. And then finally, Isaac Newton, in the 1700s in England, comes up with a law of gravity, one universal law that explains all motion in the universe. It can be applied to why an apple falls from the tree and hits them on the head. Gravity can explain why I can walk on a circular Earth and not fall off. It explains why the moon orbits Earth, why Earth orbits the sun. And so Isaac Newton again discovers the theory of gravity, one law that proves or that explains the motion of everything in the universe. He also comes up with the laws of motion. An object in motion stays in motion, and whatnot. He comes up with the idea of a prism, of white light, or of light, including all the colors of the rainbow. And then he had to actually invent his own math to make these discoveries. So if you ever take calculus in 11th or 12th grade, you've got Isaac Newton to blame for that. So when we talk about the discoveries of the scientific revolution, again, it's this big time period, 1500s to 1700s. Copernicus, he comes up with the heliocentric theory, which is the sun at the center. Galileo uses a telescope to both prove that celestial bodies are imperfect. The moon has craters, the sun has spots. And then he also proves the heliocentric theory by observing the fact that Jupiter has moons. And then Isaac Newton, he creates gravity, he creates the laws of motion, prisms, calculus, he studied optics or light, all of these different discoveries. And so all of these new ideas, they all challenge traditional sources of authority. Who was the traditional source of authority in terms of how the universe worked? Well, back then it was the Catholic Church. And so the Catholic Church, capital C, church means the Catholic Church, they felt threatened by these new discoveries. They thought, like, if Earth is not at the center, is Earth special? Is God imperfect? And so they would oftentimes ban the works of the scientists. They would burn the books. They would, Galileo was put on trial. So they banned the works of scientists. We see censorship. Copernicus, actually, when he published his theory of the heliocentric theory, he published his work posthumously, which means he published it after his death, because Copernicus knew that if he published his discoveries when he was still alive, the Catholic Church would target him. And so he did not get any credit during his lifetime for his discovery of the heliocentric theory. We'll continue to explore this conflict between the Catholic Church and scientists a little bit more. These are some of the different experiments, I guess. This is a vision of what they thought the universe looked like, every orbit being a perfect circle. These are telescopes. They were huge. And then this is how Isaac Newton, I believe, did his laws of motion experiments, basically studying gravity and acceleration. This is actually, I think this is actually the Da Vinci Museum in Florence, if I'm remembering right. I could be wrong. Okay. Not only is there are there new scientific discoveries like the heliocentric theory and gravity, but there's also a new way of thinking. Before this, people would use logic, and they would basically say, well, since God said it, since the Bible says it, it must be true. Or since the Pope or Church says it, it must be true. There are now two new ways of thinking that are kind of captured by the scientific method. Let me go to the scientific method first. The scientific method is, well, if you've ever done it in science class, you come up with a hypothesis of what you think is going to happen. And then you do a bunch of experimentation. You collect a lot of data. You look at your data, you figure out what it says, and then maybe you revise your hypothesis and you test again. The scientific method is based in evidence. It's based in observation. It's based in data. It's based in reason. And so this is using some new ways of thinking, inductive reasoning and more especially deductive reasoning. I'm going to show all of this and then we'll come back to it. Inductive reasoning, this is from Francis Bacon, who was a British philosopher. He goes from generalizations to then, from specific things to generalizations. So for example, he says, iron, when I heat up iron, it expands. When I heat up lead, it expands. When I heat up copper, it expands. 3 different specific observations. Therefore, all metals must expand when heated. Collecting specific data and making a general conclusion based off of that. On the flip side, René Descartes, who was, I believe, a French philosopher, although I could be wrong, he used deductive reasoning, which is the opposite, going from a general principle to then specific observations. If you've ever done geometric proofs, I don't know if they do that in math class anymore, this is deductive reasoning. For example, you might say all metals expand when heated. Iron is a metal. Therefore, iron will expand when heated. So again, inductive reasoning and deductive reasoning are doing basically the same thing, but in opposite orders. Inductive reasoning starts with an observation, then you come up with a theory based on that. Deductive reasoning comes up with a theory, and then you make your kind of predictions based off of that. The idea here, though, the key idea here is that both of these are based on observations and data. So I'm going to just put this as the scientific method as kind of the key phrase. And it basically says that we come up with theories, or scientists come up with theories based on, well, based on observation, based on experiments, based on data, and based on reason. It's not based on logic. It's based on evidence. It's based on fact. And I'll just say that this incorporates inductive and deductive reasoning. If you don't remember what those 2 words mean, don't stress too much. As long as you remember what the scientific method is, you should be good. And I'm going to bold some key terms in there. Okay, so a little bit more example here. Some examples of inductive reasoning of collecting that evidence first. Tycho Brahe was a scientist who worked in between Galileo and Newton, I believe. He collected a bunch of data. He spent years and years and years just watching the movement of the stars, watching the movement of the planets in space, tracking their movement across the skies. He actually, if I remember right, he actually passed away before he could make any conclusion, but his assistant, Johannes Kepler, took all that data and made some conclusions. So it's using evidence, using observations to come up with a theory. Deductive reasoning is the opposite. It's like proofs in mathematics. It's proceeding logically from one certain truth to another. René Descartes most famously said, "I think, therefore I am." What is the most basic thing that I know? I'm thinking right now. And if I'm thinking right now, I am existing. Now, he went a couple other logical leaps from there to say, if I'm thinking, then I have reason, I'm rational. If I have reason, God must exist because he gave me that gift of reason. There might be some logical leaps in there depending on your beliefs. But again, the idea of deductive reasoning is using logic to kind of move from theory to theory. But again, all of this, it's based on observation, it's based in data, it's based in using reason. Now, scientists did not do their work in isolation. We already saw how they were affected by religion. The church was often threatened by scientists. They were also affected by politics, by governments. So monarchs would oftentimes sponsor scientists. Monarchs would oftentimes pay scientists to do work for them. And the idea was to try to glorify the state. England is able to get all the honor and prestige because Isaac Newton made his discoveries in England. Or René Descartes gives credit to France for his discoveries. And so the two most famous examples of these, Charles II, who was the monarch after the English Civil War, he created the Royal Society, which was actually independent of the government, which makes sense for England, I guess, with a limited monarch. But the Royal Society allowed English scientists to work together, to collaborate. The French, meanwhile, Louis XV, the son of Louis XIV, he creates the French Academy of Sciences, which also was the king spending state money so scientists can do their research. But the goal of the French Academy of Sciences is to glorify the king. If a French scientist makes a discovery, you better believe King Louis is going to take credit for it. It fits into that idea of mercantilism and absolutism. So again, when we talk about influences on scientists, what they were influenced by, I'm actually going to plug in this church part here. Sorry if you already took notes on it. So we'll say they're affected by religion in that way. And then they're affected by politics as well, because many monarchs would create scientific societies. So we have the English Royal Society, the French Academy of Sciences. If you don't remember the name, but you remember France and England did it, then you're good. And this did both two things. This encouraged collaboration between scientists, and the discoveries would kind of glorify the state or the crown. Now, this idea of collaboration is super important. Isaac Newton, when he made his great discoveries of gravity, he famously said, and I'm paraphrasing the quote, "The only reason why I can see so far is because I'm standing on the shoulder of giants." By that, he meant, the only reason why I am able to make this discovery is because Galileo came before me, Copernicus came before him. We're building off of each other's ideas. And so this idea of collaboration was super important. And then to wrap us up, kind of the scientific culture, or the culture of the scientific revolution. Curiously enough, every single scientist was deeply religious, either Catholic or Protestant. The Catholic Church oftentimes felt threatened by these scientists. They felt like the scientists were questioning the existence of God. But in the opinion of scientists, they were actually proving the existence of God. Copernicus was a deeply religious man and believed that by discovering the mathematical laws that regulate the universe, he was discovering God's laws. Galileo also famously wanted to reconcile religion and science. Galileo almost felt threatened, or not threatened, he felt insulted almost that the Catholic Church would call him a heretic and ban his work. Because in Galileo's mind, religion and science can coexist. Okay, he makes these discoveries, but God created this universe. And by studying the universe, by studying science, we can better understand God's world. Isaac Newton, same thing. By discovering the math behind the universe, you're discovering God's creation. So oftentimes motivated by religion, which might seem ironic, given that the Catholic Church was oftentimes trying to burn them at the stake, essentially. Another aspect of the scientific culture is collaboration. There's that quote, "If I've seen further, it's by standing on the shoulder of giants." Scientists working together, building off each other. And then one of the other criticism of scientists, other than they're heretics and they're doing blasphemy and questioning God, they were oftentimes criticized as being a mystic or even being a magician. People didn't understand the science. They didn't understand, Isaac Newton says that there's an invisible force called gravity that controls the movement of every body in space. That sounds a lot like, to us, that sounds like the Force, or it sounds like magic. So lots of people who didn't fully understand the math would criticize these scientists as mystics or magicians. Isaac Newton himself even famously tried to obtain the Philosopher's Stone, which, if you've read Harry Potter and the Sorcerer's Stone, it's called the Philosopher's Stone in England. The Philosopher's Stone was rumored to grant eternal life to whoever would find it. So in the Harry Potter stories, Nicholas Flamel finds it and is 300 years old or so. So this is a really, really bad meme that, whatever. Isaac Newton and the Philosopher's Stone, that's bad. I assume none of you are laughing at home, so I'm just going to go back. And so I'm going to finish this off by talking about kind of the characteristics of scientific culture. They were oftentimes motivated by religion. There's collaboration. And then they were oftentimes seen as mystics or magicians. And I'm going to add here from motivated by religion. Scientists believed that by studying the universe, they could better understand God. By studying the universe that God created, we can better understand God. So wrapping up here, we can fit everything on one page. Awesome. Pause if you need to. When we talk next, we'll talk about chapter 10, the Age of Reason, and how philosophers take these new discoveries and apply them to government, society, religion. But for now, we have our key discoveries, Copernicus, Galileo, and Isaac Newton. We have our new way of thinking, the scientific method, which is again all about observations, experiments, data, and reason. And then we have the influence of both religion and politics on these scientists. Pause if you need to.